earlier when it happened, you were like, oh shit, I don't even have anything on the door, and you're like, I gotta cover that up.
Today, notes were a continuation from Wednesday, the 21st of February, and today is the 22nd. And when you see this, it'll probably be the 23rd on Friday. Okay, so make sure you have these notes filled out, and then I'm going to give you a worksheet that follows this, and there will be a video on that as well, all on your Google Classroom. So let's start. So U6-1 is completing the square. So we've already learned how to solve equations, solve quadratics by factoring, and today we're going to do it using two other methods. One of them is called the square root method. And you will use this if you have an x squared in the problem, like by itself, or a binomial square, something like this. If you see something like this by itself, you can get rid of the square by square rooting both sides. Okay, so here's an example. If you have a squared equals b, to get rid of the square, you're going to square root both sides. Now when you do that, you have to put a plus or minus in front of the right side because there's two answers. We're also going to be completing the square. That's when you have a trinomial in this form right here. So it's already like a trinomial, but it's best to complete the square when this a is 1 and when this b is even. That's when it's the easiest. If it's something other than 1, or this is odd, and you have another way of doing it, you should probably try the other way. But if you don't know any other way of doing it, it's okay to do it. So it's going to make it a little bit harder. Okay? So we're going to recall a couple things. These are called perfect square trinomials. The reason they're perfect square trinomials is because the ends are perfect squares. And because this term right here is half of the middle term. Half of 6 is 3, and 3 squared is 9. So the third term should be half of the middle term squared. If that's the case, then you can factor it as a binomial squared. So you're going to factor it. So instead of writing two factors like this that are the same, because that's what the two factors are, factors of 9 that add up to 6, you're going to write with one of them, but with a square, because there's two of the same thing. So we're not going to write it like this. We're going to write it like this, binomial squared. And this is just one step of your completing the square process that we're going to do later. So this one, this trinomial, perfect square, perfect square. Half of 10 is 5. 5 squared is 25. So this is a perfect square trinomial, which means it can be factored with two of the same things. Square root of x squared is x. Square root of 25 is 5. Another way to get the 5 other than taking the square root of 25 is taking half of 10. That's always going to be true. Like half of 6 is 3. This one is a perfect square trinomial because perfect square, half of negative 16 is negative 8. Negative 8 squared is 64. So you can factor this. When we factor it, half of negative 16 is negative 8. So the sign always goes or matches that middle term. Square root of 64 is 8. So now, our first method, x squared equals 9, is we're going to do the square root method. Because all we have is this x squared, and to get rid of it, we can just square root. So we have x squared equals 9. So to get rid of the square, you're going to square root both sides, put a plus minus, and x is plus or minus 3. Two answers. There's always two answers. The way that we did it the other 2 days was a zero factor theorem, which means if you have this, you have to get one side equal to 0.
No, you're good. Just more.
And then you have to factor. Factor, and then your answers are negative 3 and 3. So it's the same answers. Two more steps than you had to do on this one. So I prefer this one right here. And you'll notice that in this trinomial form, in this problem right here, you're missing this linear term. If you're missing the linear term like that, that's when you can do the square root method. But when you have an x to the first term, it's best to do the completing the square process, which I'll do on the back. So on this next one, you have x squared equals negative 16. So to get rid of squares, square root both sides. And x is plus or minus 4i. X equals plus or minus 4i. Now on a graphing calculator, if you graph this, it would look like this. It would be 16, and then it would not cross the x-axis. That's what imaginaries look like. Where the one we just did, 3 and negative 3 are real. So it looks something like that. You can actually see it crossing at -3 and at 3, where in this one, it doesn't even cross the x-axis at all because of the imaginary. So this last 6 on the front page are all the square root property method. You're just going to be square rooting to get rid of the squares. So in this first one, you're going to square root both sides. So x is plus or minus, and then we're going to do a 50 factor tree. So that's 5 square root of 2. Divide by 2. X squared equals 16. X equals plus or minus 4. On this one, we're going to subtract 9 to the other side, and then we're going to square root. Now this time, because there's a negative under the square root, we're going to pull out an I, but we're also pulling out the 3, so it's 3i. But don't forget the plus or minus. So now, a lot of you guys are going to want to distribute, but in PEMDAS, you have to do exponents before you multiply. So do not distribute. Don't distribute. And don't FOIL. Instead, we're going to get rid of these numbers by doing inverse operations. So to get rid of a multiplication of 2, you will divide by 2. Actually, let's change 25. I don't like this number. Let's change this to a 32. Change this to a 32. Now divide by 2. X plus 1 squared equals 16. Again, I changed that number because I don't like 25 divided by 2. And I want to make sure you understand the process, so we'll make it with an easier number. So now we have this. So to get rid of a square, we're going to square root both sides. So x plus 1 equals plus or minus 4.
Wait, did you guys grab it at the same time?
Then you're going to subtract 1 to both sides to get this. If this 4 does not contain a radical or an I, you're going to split the plus or minus up and get -1 plus 4, which is 3, and -1 minus 4, which is -5. And these are your two answers. So on this one, to get rid of a square, you're going to square root both sides, plus or minus. 28 factor tree is 2 and 14, which is 2 and 7. So bring a 2 out. And then when you subtract 5 to both sides, we're going to put the -5 in front of the plus minus. And because there's a radical involved, you do not have to split the plus minus up. And that's your answer. So on this one, we're going to square root both sides. Bring the I out. Look through the paper. Factors 18 is 2 and 9. 9 is 9. And you're going to bring a 3 out. Like this. And then you're going to add 3 to both sides. And these are your answers. Back side. So this is where the fun starts. This is the completing the square step. Solve. People are making fun of me because I said fun. It is fun. Math is what you make it. I like it. I do get paid for it. That's why it makes it more fun. But I used to like this when I didn't get paid for it. All right, so solve a quadratic equation by completing the square. Okay, so really you only want to do it if the coefficient is 1. Okay, so this first one right here, the coefficient is 1. So this one's an easy one. This one, not so easy. So I don't even know if I want to do this one. You know what? Let's not do this one. We'll do the challenge one down at the bottom. Otherwise, you're going to have to divide both sides of the equation by the coefficient of x squared. So like in the challenge problem down here, since s is not a 1, you would want to divide everything by 3. And get x squared plus 2x minus 4/3. That's how you would start the problem. That's what step 1 means. So if you don't have a 1 there, divide everything by 3. So like in the one I just crossed out, you would divide by 2 to get this. But we're not going to do this one. All right. Isolate all variable terms on one side of the equation. So what you want to do is anything that has an x, isolate it on the left-hand side. And that means you're going to have to add 5 to the other side, like this. Now the reason I have a big gap here is because we're going to complete the square here. We want a perfect trinomial. 5 wasn't a perfect square, so we moved it. If you are, don't have something that's perfect, you can create something that's perfect. So whatever you're going to add to this side, you add to this side. So to fill in our missing perfect square here, you're going to find it by taking half of the middle term. So half of 2 is 1. And 1 squared is 1. We're going to add that here and here. Then we're going to factor. So it says right here, factor the resulting perfect square trinomial and write it as the square of a binomial. So we're going to factor this, and we're going to write it as a square of a binomial. So the square root of x squared is x, and half of 2 is 1. 5 plus 1 is 6. And to solve for x, we're going to square root both sides. X plus 1 equals plus or minus square root of 6. And we're going to subtract 1, and x equals negative 1 plus or minus the square root of 6. Again, because it's a radical 6, we're not going to split up the plus or minus, and this is your answer. So let's do the one below it. So keep any term that has an x on the left-hand side, but put plus blank. And then move this negative 6 to the other side. So we're going to subtract 6. Give it a blank. What is half of the linear term? 2. So 2 squared is 4. Add 4 to both sides. So this is going to be x plus half of 4 is 2 squared. That's a binomial square. Negative 6 plus 4 is negative 2. Then we're solving for x. So to get rid of a square, you square root both sides, and you get x plus 2 equals plus or minus I radical 2. And then subtract 2 to the other side to get this answer. So question D here. The x's are already on the left-hand side. The 4 is already on the right-hand side, so we'll leave those there, but let's spread that a little bit. So what's half of 3?
Sorry, you got it.
Half of 3 squared is 9/4, because 3 squared is 9, and 2 squared is 4. So you take half of the middle term and square it. Half of anything, you just divide by 2. So we're going to add 9/4 to both sides. So when we go to factor it as a binomial square, you always just take half of this term, which is 3/2, which is also the square root of 9/4. 4 plus 9/4, if you punch this in your calculator, is 25/4.
No, the first one is cheeses, not the green guy.
So if you square root both sides, you get plus or minus 5/2. Then we're going to, oh, I already did square root, sorry. I did square root, so the square is gone. Then you're going to have to subtract 3/2 to both sides. Now, since this does not have a radical or an I, you have to separate the plus minus. So here's the plus. Negative 3 plus 5 is 2/2, or 1. Negative 3 minus 5 is negative 8/2, or negative 4. 1 and negative 4. So let's do this challenge problem. I've already divided by 3. Remember that from the first step? So half of 2 is 1. So we, oh, I forgot to set it up. We have blank here. Let's add the 4/3 to the other side, blank. So we're going to add 1 here and 1 here. And then we're going to factor it like this. 4/3 plus 1 is 7/3. Then we're going to square root both sides. This is going to be radical 7 over radical 3, which we're going to rationalize to get x plus 1 equals plus or minus square root of 21/3. Then if we subtracted 1 to the other side, you'd get something like this. That'd be your answer. So here's a word problem that uses exponents like this in parentheses. A is the amount of money in the account. P is what you start with, the principal. R is the rate that it grows. And T is the time that it's going to be in the thing. So find the rate. We're going to find this. If a rate at,
Wait, pause.
you started at 800 and it goes to 882 in 2 years, what was the original interest rate? If this is a true fact. So to solve for R, you first get rid of 800 by dividing. So you would get
I'm gonna do it nails real quick.
Wait, guys.
882 divided by 800 for 1.1025 equals 1 plus r squared. So square root. I don't think we have to worry about the plus minus in here because you don't want negative money. So square root
I left my speed freeze.
of 1.1025 So 1 plus r is equal to 1.0124. Looking at right here. Subtract 1 and your interest rate will be 0.0124, which if you move the decimal 2 to the right is a 1.24 interest rate. And that's really, I don't care if you do the rest of these. Actually, let's try this one. 4. The area of a square is 196 square feet.
That's 3.
Find the dimensions of the room. Since area is equal to side squared for a square, and the area is 196, you could set it up like this. So the dimensions of the room you could just find by taking the square root of 196, which is 14.